Welcome back, students. We're going to go ahead and work on question 1b from lesson 19.1, Understanding Quadratic Functions. This one's more interesting. This one wants to know what happens when a is less than 1, but also bigger than 0. Now, I don't know if you pick up on what this means, but this is all your proper fractions. You know, proper fractions being like a third, 2/5, 3/8. In other words, the top number, numerator, is smaller than the bottom number, denominator. We refer to those as proper fractions. So what would not be a proper fraction? Well, if it looked like, and I'm trying to get red, this would not be a proper fraction if it looked like 5/4. Because 5/4, the 5 is bigger than the 4th, so that we refer to that as an improper fraction. So we want fractions that are always numerator smaller than denominator for this particular exercise. So here we go. We're given the function g of x, and g of x is equal to 1/2 of an x squared. So anywhere we see an x, we're going to plug in our first number, which is -3. So this will give us g of -3 equals 1/2 of -3 squared. Okay, here's where most people will mess up. Most people will say, I'll take the half and multiply it by the -3. You cannot do that because order of operation dictates if there's nothing in the parenthesis to be done, and right now in that parenthesis, all I have is a -3, I can't touch that -3. I have to move on to my exponent. So what happens when I take -3 and square it? I get a positive 9. But now I want half of that 9. So half of that 9 is going to be 4.5. So my answer up here is 4.5 because that's what g of -3 gave me. All right, let's move on. This time we're going to plug in -2. So g of -2 equals half of whatever -2 squared is. Well, check this out. If you take -2 and square it, don't you get 4? Well, then what's half of 4? Well, half of 4 would be 2. So now I know that g of -2 equals 2. So we'll put that 2 right there. Now, if I take 0 and plug it in here, what's 0 squared? Well, don't you still get 0? And if you take half of 0, don't you still get nothing? So your answer is 0. Now, this is interesting because the next one's 2. So instead of -2, if I plug in 2 here, 2 squared is still 4, and half of 4 is still 2, so I still get 2. And then same thing happens here. If I take 3 and plug 3 in here instead of -3, positive 3 squared is still 9, and half of 9 is still 4.5, so I still get 4.5. All right, so now I got all my algebra done. Now I just need to take this and copy it on desmos. Remember, this is not the domain and range. This is the graph settings. So it could look the same. Okay, so my graph settings, I'm going to start right here and run to right here for my x's. And it looks like I'm skipping by 1s. So I'm going to go from -5 through all my x's to +5 with steps of 1, and I have no title. Now I'm going to repeat the same thing for my y's. According to this graph, it starts right down here, runs right up here. It looks like it's counting by 1s again. So this time I'm going to start at a -2, and I want to run all the way up to 8, 9, 10 with steps of 1. Now I got everything I need for desmos, so let's run over to desmos. So here we go. I want desmos. And I want the graphing calculator. And as always, I want to start off with, a new desmos. So I'm going to hit the little icon, take off minor axes. There was no label. So I want to start at, what did we say here? We said from -5 to 5. So I want -5 to 5 steps of 1. no title for my y, and I wanted to go from -2 to 10 with steps of 1. Okay, that gets everything set up. Now I'm ready for my ordered pairs, and hopefully you wrote them down somewhere. So here we go. I want to go from -3 to 4.5, from -2 to 2, from 0 to 0, from 2 to 2, and from 3 to 4.5. Okay, now if I look closely, it looks like a parabola, except, I don't know if you can see this, it's kind of fatter or flattened out. Doesn't look like it's the same, because the last one kind of looked like this. Kind of went like that. But this one's going this way. So it's kind of flattening out. So what I want to do now is I want to go ahead and grab this guy and plug in my expression. And this one was 1/2 of an x squared. Ooh, I messed that up, didn't I? 1/2. Okay, that's not cooperating because I'm hitting the wrong button because I'm sick. Okay, now if it works out well, it should cross through every single dot, except keep in mind that right here this line goes on forever, and right here this line goes on forever. So I'm going to go ahead and grab a copy of this so I could bring it in. And now we're going to explain the last two questions, which is what is the domain and what is the range? All right, the domain is the set of all x values. The x's are all right here on the x-axis. X-axis. And the y's are up here running up and down on the y-axis. Okay, so basically here's how it works. If I were to take this line right here and keep flattening it out and flattening it out and flattening it out, remember there's an arrow here and there's an arrow here. Well, then this one would flatten out here and then flatten out here and then flatten out here, and finally it would look like this. Same thing with this one. I could flatten this one out and flatten it again and flatten it again until finally it's sitting right here and it's doing this. Well, which way is this one pointing to? Well, this one looks like it's pointing to positive infinity. And this guy over here looks like he's pointing to negative infinity. So if that's the case, I have every single number accounted for. So we refer to this as my x, which is the domain, are all real numbers. All real numbers. In other words, real numbers being every number I could ever imagine, that I could ever create, that I could point to on a number line. So that would be my domain. So I come over here to domain and let's type that in. So all real numbers. Now I want to do my range. So I come back over here to my graph, and basically I repeat the process, except this time it's in the opposite direction. Instead of running down the x-axis, we're going to be running down the y-axis. So here's what this looks like once I get all this erased. Okay, here we go. So we do the same thing, except this time I want to bring it this way and this way. And I want to keep scrunching him and scrunching him, and I don't know what just happened, and scrunching him until, wow, really? Until I get to the point where my graph is just doing this. I don't know, again, if you can visualize this, but this one's pushing it this way, this one's pushing it this way, until both lines overlap each other, and all I see is just basically one big line. So if that's the case, then that means my range starts here, which is 0, and it runs all the way through positive infinity on the y-axis. Okay, well, how do we say this? Well, we say that it starts and includes the number 0, and it gets bigger and bigger. Oops, that's wrong. That's not right. What we wanted to say was it goes bigger than this. There we go. We got to have it in the right direction. So that is everything bigger than 0 and including 0. So we come over here to my answer, and this one is going to be y is always bigger than or equal to 0. That's how you do the domain and range.